Hi everyone. In the last lecture we learned about the force terms in a constant strain triangle. In this lecture we will be solving a problem based on what we have learned in the previous lectures. So here we have a two-dimensional plate which is shown on the left hand side of the screen. We have to determine the equivalent point loads at the nodes 7, 8 and 9. We also see that a linearly distributed pressure is acting upon the edge 7, 8, 9. Now let me draw the edge 7, 8, 9. So node 7, node 8 and node 9. For every node or for any node I, the degrees of freedom will be given by 2i and 2i minus 1. So since we are asked to find out the equivalent point loads, let us denote the equivalent point loads by F. So for any node it will be F2i and F2i minus 1. So for node 7, 2i will be 14 and 2i minus 1 will be 13. Similarly, we do it for node 8 and node 9 as well. So F17 and F18. Let us begin with edge 7, 8. Okay, so we have the edge here 7 and 8, and we have the uniformly distributed load. So this is 2 MPa at edge 8 and 1 MPa at node 7. So P1 is 1 MPa, P2 is 2 MPa, let us write down the x and y coordinates. So x1 is 100 mm, y1 is 20 mm, x2 is 85 mm and y2 is 40 mm. Now to find the length of 7, 8, it is under root of x1 minus x2 the whole square plus y1 minus y2 the whole square. And on substituting the values of x1, x2, y1, y2, we get the length of 7, 8 is 25 mm. Next, we find out the terms C and S. So C is given by y2 minus y1 upon the length of the member. So this is nothing but cos theta, and sin theta S is given by x1 minus x2 upon length 7, 8. This will give us 0.6. Next, we find out what is Tx1, which is given by minus P1 into C. Substituting for P1 as 1 and C is 0.8, we get 0.8 megapascals. Similarly, Ty1 is given by minus P1 into S. We will get minus 0.6 megapascals. Tx2 is given by minus P2 into C. So minus 2 into 0.8 minus 1.6 megapascals, and Ty2 is given by minus P2 into S minus 2 into 0.6, which is minus 1.2 megapascals. Next, we find out the vector T, and that is for the length 7 and 8. The formula is given by thickness into the length of the member upon 6 into 2tx1 plus tx2, 2ty1 plus ty2, tx1 plus 2tx2, and ty1 plus 2y2 transpose. The thickness of the element, if we see in the diagram, it is given as 10 mm. So here it was mentioned as 10 mm. Length is 25. So let us now substitute for all these values, and we get so 2 into tx1 is minus 0.8 plus tx2 is minus 1.6. 2 into ty1 is minus 0.6, ty2 is 1.2. On multiplying and adding these terms, we get minus 133.33 minus 100 minus 166.67 minus 125, and the unit will be Newton. So these loads what we have just calculated are nothing but F13, F14, F15 and F16. The same procedure we have to repeat for the edge 8, 9. And here we have 3 MPa and 2 MPa. So P1 is 2 megapascals, P2 is 3 megapascals, X1 is 85 mm, Y1 is 40 mm, x2 is 70 mm and y2 is 60 mm. The length of 8, 9 is under root of x1 minus x2 the whole square plus y1 minus y2 the whole square, and on substituting the values we get 25 mm. Now C is given by y2 minus y1 upon the length of 8, 9, and this is 0.8, and S is x1 minus x2 upon length of 8, 9, and this works out to be 0.6. Again we find out here Tx1, Ty1, Tx2, please note here that P1 and P2 are 2 and 3 megapascals respectively. P2 into S, which is minus 1.8. So to find out the equivalent point force, we use the formula TEL upon 6 . 2 Tx1 plus Tx2 2 Ty2 plus 2 Ty1 plus y2 Tx1 plus 2 Tx2 and Ty1 plus 2 Ty2. This transpose, and on addition and multiplication of these terms we get minus 233.33 minus 175 minus 266.7 minus 200, and the unit of this is Newton. So now here what we have found out is F15, F16, F17 and F18. Now for the entire 8, 7, 8, 9, it will be F13, F14, F15, F16, F17 and F18. So combining the two vectors, F13 is minus 133.33 and F14 is minus 100. F15 is the addition of minus 166.67 and minus 233.33. The addition of these two terms is minus 400. F16 is the addition of minus 125 and minus 175. and it is minus 300. F17 is minus 266.7 and F18 is minus 200. The units of this are Newton. So this is our final answer. We were asked to find out the equivalent nodal forces or point loads at the nodes. Hence the problem is solved. Thank you.